Let's quickly solve for the value of x. Okay, now first let us change this to base 3. Yes, because 27 is the same thing as 3 to the power of 3, right? So we can write this as 3 to the power of 3 raised to the power of x plus 3 to the power of x is equal to 68. Now recall that a to the power of m raised to the power of n, okay, can also be written as what? A to the power of n raised to the power of m. Okay, now let's quickly solve that. Let's quickly apply it here. So if we do that, we have 3 to the power of x raised to the power of 3 plus 3 to the power of x is equal to what? 68. All right, now we have 3 to the power of x, 3 to the power of x. Let's call it let's give it an alphabet, okay, to simplify the equation. So we say let 3 to the power of x be equal to a, right? Now if we say that, that means we change this equation to a to the power of 3 plus a is equal to 68. Now we can now rewrite this as what? A to the power of 3 plus a minus 68 is equal to 0. Now when you look at this, notice that we have formed a cubic polynomial, and there are several ways to solve that. So I'm going to leave an end screen and the link to a video where I gave a detailed tutorial on how to solve your polynomial, your cubic polynomial, several ways you can use to solve it. But I'm going to use just one of the methods here to get the value of my a. But recall that we are not looking for the value of a, rather we are looking for the value of x. Okay, so let's go ahead and solve then. Now according to the method I want to use, I'm going to use try and error to get the first value of a, then I'm going to use synthetic division to get my quadratic equation. So looking at this, by trial and error and by mere looking at it, you can see that your a is 4, okay, because 4 to the power of 3 will give you 64, and 64 plus 4 will give you what? 68. So 68 minus 68 will give you 0. So our a here is equal to 4. So we have that a is equal to 4. So we are going to use this 4 to synthetically divide this, okay. Now we are going to bring out the coefficients of this polynomial, the coefficients of each term. So we have 1a to the power of 3, so 1. Now we're supposed to have a squared before we have a. That means the coefficient of that one is 0, because it's when 0 multiplies anything that you get 0, okay. So since it's not here, it means it's 0, and that means that the coefficient is 0. So we are going to leave 0 here. Then the coefficient of a is 1 as well, and our constant is minus 68. So we are going to bring down 1, bring it down. Now 4 times 1 will give us what? 4. We add 0 plus 4 will give us 4. 4 times 4 will give us 16. Now 1 plus 16 will give us 17. 4 times 17 will give us 68. Minus 68 plus 68 will give us 0. Okay, so that means that if a is equal to 4, it simply means that a minus 4 is equal to 0, right? And that this is also equal to 0. So we can write that a minus 4, okay, multiplied by this will form our what? Our quadratic equation. So that means that we have 1a squared. So we are going to have a squared plus 4a plus 17 is equal to 0. Okay, so that simply means that a minus 4 is equal to 0, and a squared plus 4a plus 17 is also equal to 0. Now like I said, we are not looking for the value of a, we are actually looking for the value of x. Okay, now from here we can say that a is equal to what? This will cross to become positive 4. Now we have a1, so let's use it to find the value of our x. Then we come back here, find our a2 and 3, and also find the value of our x. Now we are going to continue from here. Let's continue from here. So we have a1 is equal to 4. Now recall that a is equal to what? 3 to the power of x, right? Let me show you. 3 to the power of x. So you're going to have a is equal to 3 to the power of x. Now we found our a to be equal to 4. So we can say that 4 is equal to 3 to the power of x. Now look at this. There is nothing you can do here except to introduce logarithm to both sides of the equation. So we can write that log 4 is equal to log what? 3 to the power of x. All right. Now we have that log 4 is equal to, when you have a power, according to the law of logarithm, that log a to the power of b is equal to b multiplied by log a. Okay, is equal to b multiplied by log a. So that means that we can write this as what? X log what? 3. Okay, now to get the value of x, let's divide both sides by log 3, divided by log 3. Okay, now log 3 is going to cancel log 3. So we have that x is equal to log 4 base 3. Yes, when you have log and both of them are in the same base, this becomes your number and this becomes your what? Your root, your base. Okay, so this is our x, the first value of our x. Now let's go to the second value. So here we have that a squared plus 4a plus 17 is equal to 0. Ooh, I've cleaned it. So we have a squared plus 4a plus 17 is equal to 0. I just hope I've not made any mistake. Okay, so I believe this is what we have there. I believe. Now when you look at this, we have we are going to solve this using quadratic equation formula. But before that, let's check if we can get real root from here or complex roots. Now we are going to use the discriminant to check. Okay, let's use the discriminant to check. So using the discriminant, we can see that the discriminant is b squared minus 4ac. So this is the discriminant and this is equal to our b is the coefficient of a, which is 4. So it's going to be 4 squared minus 4 multiplied by our a is 1 while our c is 17. So our discriminant is going to be 16 minus, now 17 times 4 will give us 68. So notice that our discriminant will give us a minus what? Minus 52, right? Yeah, minus 52. So notice that this is what? This is a negative number. That simply means that if we should solve this, we are not going to get real root from here. We are going to get complex root. So there is no need solving it. That means the only real solution to our x is what? X is equal to log 4 base 3. Thank you so much for watching and have a lovely day.